This is an example of complex numbers, and we have different ways of expressing complex numbers. The first one is z is equal to a plus b times j. This one is called Cartesian form. Then the other form is r into the cosine of theta plus j sine of theta. How do you call that? That is called polar form. Then we have r exponential j theta, and that is called the exponential form. When you are writing it in exponential form, ensure that that theta, which is the argument, is in not in degrees, in radians. So what we do, we write this one as 3 plus j7 divided by -2 minus j5. To rationalize the denominator, in other words, we change that number in the denominator to be a rational number, a number that can be written as a fraction. We multiply both the numerator and the denominator by the complex conjugate of the denominator. So we have -2, we have j5, and this one is -2 j5. To get the complex conjugate of this one, we write the numbers the way they are, then we change the sign between them. This is negative, we convert it to positive. This is negative, we convert it to positive. And that forms the complex conjugate of the denominator. Now, to be efficient, we need to use brackets so that our expansion is okay. Now we work it out. We expand the numerator algebraically. So we have 3, the first term here, open the second term, -2 plus j5. Then we take the second term, that is plus j7, into -2 plus j5. Then we divide all this by, expand this one also as -2 into -2 plus j5. We take the second term, negative j5 into -2 plus j5. Then we do the expansion in the normal way. This times that becomes -6 plus, this times that is j15. This times that is minus j14. This times that becomes, you can write first as plus 35 j squared. Then we divide this one by that times that is positive 4, that times that is minus j10. Then we have this times that is plus now j10. This times that becomes minus j squared 25. Okay. Put like terms together and remember one thing, that j squared by definition is -1, because j from definition is the square root of -1. Now use that and substitute wherever there is j squared. So this gives us -6. If you multiply here j squared by 35, it becomes -35. Then we have 15j minus 14j gives us plus j. Divide this one by, this is 4, that is j squared, which is -1 plus 25. Because this will cancel with that, because one is positive and the other is negative, and this gives us -41 plus j divided by, this is 29. So you can split it into the real part and the imaginary part. -41 divided by 29 plus 1/29j. That is the simple form of our fraction as a complex number. Now from here we are going to get two things: r, which is the magnitude of that complex number, and theta, which is the argument. We know that r is given by the square root of x squared plus y squared. In our case, x is that part which is equal to the square root of negative 21 over 29 squared. We add y is 1 over 29, then we square that. When we work it out, we get the value of r s sub 2, which is the same as 1.41. Now to get the argument, we need to be a bit careful there. To get the argument, first we get it as the tangent inverse of y divided by x, which is like b over a. So this one gives us the tangent inverse of 1 over 29 divided by negative 41 over 29. But remember now, we need to be careful because we are looking for the correct angle. In this case, the x coefficient is negative and the y coefficient is positive, which means the correct angle is supposed to be in the second quadrant. In that case, we are going to take that value, then we add 180 degrees or pi. And when you work it out, you'll get 178.60 in degrees. When you convert that one into radians, remember pi radians is 180 degrees, right? So when you convert it, what you get? 3.11 radians. We have obtained r, we have obtained theta. R is the magnitude of the complex number and theta is the argument. Okay. Now we can write our complex number 3 plus j7 divided by negative 2 minus j5, and when you reduce it, it gives you negative 41 over 29 plus 1 over 29 j. And this one, if you so wish, you can write it as this one is written as Cartesian form. You can write it as polar form, which is 1.41 into cosine of 178.6 degrees plus j, the sine of 178.6 degrees. We are not asked to do that, but we are requesting to write it in exponential form, where r is 1.41 exponential j. And we say you must write your argument in radians. So this is 3.11 radians. That is our answer to that question. That is how you could easily work that one out. The next lesson, we're going to do a few more of these ones and we see how they vary from question to question, but basically that is the concept. Any question, please? Thank you very much for listening. Prepare for the next lesson.